This question is based on viscosity. So there is a spherical ball which has a radius r. It is falling in a viscous medium, and that medium has negligible density. So this point is much important. So here the terminal velocity is v, and in another case, same ball, I mean another ball with same mass and radius 2r, it is falling. So for this case, we need to find the terminal velocity. So since it is viscosity and terminal velocity, you are not supposed to use the expression which you have learned already, where the viscous, along with viscous force, Bouillon's force will also be there. Since here medium of negligible density is mentioned, so we need not to consider Bouillon force, which is also negligible. So if we consider the ball whose mass is m, then only two forces are going to act. The gravitational force will act downward, and force due to viscosity, it will act upward. So terminal velocity means the velocity at which both the forces are going to be equal. So Fg is going to be equal to Fb. In the previous case, we will have Bouillon's force also, so the expression changes. Since the negligible density is given, so we need not to consider it. Gravitational force, which is mg, Bouillon's force, viscous force, we can write using Stokes' law, that is 6 pi eta r into v. Eta is coefficient of viscosity, r is radius, v is the speed. So terminal velocity means it's a velocity at which the net force is zero. So here the two forces are equal and they are in opposite direction. So we can just rewrite this, or maybe this mass, gravity, and all other stuffs are constant. Only this radius and speed are variable. So I can write speed is inversely proportional to radius. So in the first case, v1, the speed is p and radius is r. In the second case, let's consider speed is v2 and the radius r2. So r2 is 2r. We need to find the v2. So I can write v1 is directly proportional to r1 and v2 is directly proportional to, so this is 1 by r1, this is 1 by r2. Yeah. So v1 by v2 will be equal to r2 by r1. v1 v2. So v2 equal to r1 by r2 into v1. r1 is r, r2 is 2r, v1 is v. So v2 equal to v by 2. The terminal velocity of the second ball is going to be half of the first ball.